Okay, now we have this quiz problem, f of x equals x squared, g of x is one over x. Find h of x, which is f of g of x, k of x, which is g of f of x. Give the domain and range of each. Okay, well, before we do this, because when people did this, there were all kinds of extraneous things in about half people's papers, okay? So we're gonna kind of go through the sequence. If f of x equals x squared, what's f of two? Well, two has replaced x, so two has to replace this x. F of two is two squared. What's f of a? Well, a has replaced x, so it has to replace this x, and you get f of a equals a squared. What's f of g? Now, g isn't necessarily g of x. G is just the letter g, because I didn't say g of x, okay? F of g, g has replaced x, so you got g squared. Okay. Now, f of g of x, what has replaced x? G of x has replaced x, so g of x has to replace this x, which gives you g of x quantity squared. Okay, what's g of a? Well, here's your rule for g. A has replaced x, so it has to replace this x. You're going to get 1 over a. What's g of f? Well, f is replaced x, so you're going to get 1 over f. And g of f of x is in the place of x, so f of x has to be in the place of this x to get 1 over f of x. Okay, now, g of x is 1 over x. I've asked everybody to write these out. Keep writing this out. Go ahead and write this one. F of x, of course, is x squared. So what's f of g of x squared? Okay, so g of 1 over x squared would be 1 over x squared. Now that simplifies. Turns out that just equals x squared. F of x equals x squared. What's f of g of x squared? Well, it's just g of x squared squared. I'll give myself much room. Hopefully you can read that. And you must be what something happens. Okay. Now, this and this have nothing to do with this composite that I've asked for. None of this is relevant in any way to this composite. Okay. But I was seeing stuff like this when you were doing the composites. Okay. Might not have been exactly this. You're getting formulas for g of x in the g of x function, or formulas for f of x in the g of x function. And it's getting garbled and confused. You got to follow it straightforward. Substitute, substitute, substitute. Okay. And if you focus on that, you're more likely to get it right. Okay. So let's just see now. Here again. F of g of x equals, that's your h of x. H. Okay. F of g of x is what? Well, what has replaced x? G of x. X hasn't been replaced by x. X hasn't been replaced by g. X has been replaced by the whole g of x. And you want to write that out as g of x squared, not g of x squared squared. Okay? G of x squared. It's not this, it's not this. And of course, then you can substitute for g of x. And that's quantity 1 over x squared, which we'll just write as 1 over x squared. It's 1 squared over x squared, but 1 squared is just 1. So you have 1 over x squared. Okay. K of x equals g of f of x equals x has been replaced by f of x. It's 1 over f of x. And f of x is x squared, so it's 1 over x squared. So it turns out that h of x and k of x are identical. Okay. Now, I'm going to say this a little different. I'm rethinking it. So, make a statement. Actually, I'm going to write down this what I have, but there'll be something in our next head. For f of g of x, is there any number we can't plug in for x? Well, what's the first thing x gets plugged into? It gets plugged into the g of x function, right? Is there any number that you can't be plugged into the g of x function? There is. Show me what it is with your hands. Can't plug in 0 because 1 over 0 means 1 divided by 0 means how many zeros does it take to count to 1? How many zeros does it take to make 1? You can't do it. It's undefined. Does not exist. Okay? And you want to understand that because people still, no matter how many times I say that, it doesn't really sink in for many. Some it does, but for most it doesn't. And I see them dividing by 0 and allowing 0 into domains where it doesn't belong. Okay? So abbreviate does not exist. Okay? Makes sense? Again, because you can't count to 1 by zeros. You count to 1 by point ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Takes 10 of them. Okay? But if you try to count by zeros, you go 0 and 0, 0 and 0, 0 and 0, 0. And after an hour or two, you get the idea that you're not going anymore. Okay? Well, it doesn't take you even a couple of steps to see that. Takes you an hour or two, it's worth it, but you know you don't need that. Okay? Okay, so so automatically, since 0 can't go into g of x, 0 is not in the domain. Since it's not in the domain of g of x. Okay. Now, the next thing you got to check for the domain is, are there any numbers that g of x can be that f can't handle? Well, f is the squaring function. You can square any number. So any number that you can get out of g of x, you get it out of f of g of x. Okay. I mean, you can plug it into f of g of x and you get the result. There's no other number that you can't put into g of x. You always get a number. Okay. Now, if you've been through the first assignment on functions, you know that the graph of g of x looks like this. In my class, we've graphed the part of it that's in, let's say, a box like this. Okay. We haven't gone outside of that box yet, but if you follow the trend, you see that these numbers, from here to here, the number cuts in half, from here to here, the number cuts in half. Every time you move one to the right, the number is going to cut in half. And you keep cutting it in half, cutting it in half, cutting it in half. You never get to zero. The numbers get really tiny, and they get tiny really pretty fast. Okay. By the time you're up to the 30th number, you got like 1/10000000th. Okay. And it's hard to even imagine for most people what a billionth is. It's really tiny. And you've only gotten started. Okay. After 100 steps, let's say after a little over 200 steps, you have 1 over a number that's bigger than the number of particles in the universe, subatomic particles. Okay. You can imagine 250 steps, but you cannot imagine how many particles there are in the universe. You write it down, it's like 10 to the 80 something. Okay. You can figure it out if you know a few things, but so these numbers get really tiny. So you say that this approaches an asymptote at the x-axis. Okay. And if you go this way, from here to here, the number gets twice as big. From here to here, it gets twice as big. Okay. And it's going to go, if you go halfway to the y-axis, it'll get twice as big again. Well, twice as big keeps growing. Okay. After 10 steps of twice as big, you got 1,000 times as big. 20 steps, you got over 1,000,000 times as big. Okay. So there's no limit to how big these numbers get, no limit to how tiny these numbers get. So g of x can be any number except 0, because you don't ever get to 0 when you cut things, keep cutting something that's not 0 in half. Okay. So it's this, and that's real familiar to you. You had to go from math assignments. Okay. So f of x is going to square all numbers except 0, because this is all numbers except 0. f of x can be any number except 0. All right, got a question? Okay, there's a question on what this U type thing looks like. It's not really a U, but it stands for union. So union starts with U. So you can make that association if you want. Union means this is a set. A number's in this set. If it's in this part of the set, and it's in the set if it's in this part of the set. Okay? It's just like you're lumping together all numbers up to 0 and all numbers after 0. So the only number that you're not lumping in here is 0. But union means it's in this set. It's in the union of sets. If it's in either one of these. Okay? It's in this or in this. That help? So we kind of take that statement. Also, you can look it up and you want to clarify my statements for what somebody else has to say about it. Look at what the text has to say. Okay. Well, that's all I'm going to say about it. That's all I'm going to say about these functions. But this is how you think about domain and range. For f of g of x, you ask yourself, okay, is there any x that doesn't work in G? Okay. Then you ask, okay, well, what are the numbers that you get out of G? Do any of those numbers fail to work in F? In this case, F is a square function, so, okay. You can square any number. And then you ask yourself, okay, take all the numbers you get out of G and plug them in. What set of numbers do you get? That's the range of f of g of x. And I should have said that f of g of x all numbers except 0, which again you write negative infinity 0, union 0, open sets. Open at infinity because infinity isn't a number. Which means you include all numbers forever. Okay. And open here because 0 isn't included. Domain and range can be a tricky concept. You want to keep looking at it. Okay. It's just one example. We don't have time to do a huge number of examples because we do need to move on and talk about transformations. Okay, now I'm not sure. We talk about f of that. Well, briefly. G of f of x, G of x is x, 1 over x. If x is replaced by f of x, you got 1 over f of x, which is this. And f of x is x squared, so it's 1 over x squared. Okay. You can put any number at all into f, including 0, but and then you get any positive number out of f. Uh-oh. Yeah, I was careless here. Just trying to make one point and screwed up. I'm gonna have to wipe this out. Let's say it right. What I said there is kind of wrong. They're right. Squares can't be negative. And x can't be zero. There's another connection there. Yep. G of x can be any positive number, okay? Because g of x is going to give you anything but zero. So f of g of x can't be zero. And I again need to give you trying to get the space here. Not succeeding. So f of g of x can't be zero. And can't be negative. Okay. Now, does that make sense? Is that kind of misled you there for a minute? It's hard to get that out of your head. So again, g of x can be any number but zero. Squares can't be negative, and g of x can't be zero. So f of g of x can't be zero because g of x can't be zero, and it can't be negative because squares can't be negative. Okay. So the domain of f of g of x is the interval 0, infinity. Okay, that excludes the negative numbers, it excludes 0. Okay, again. You got to know, ask the right questions, kind of think about the way I'm asking the question. Okay, now, g of f of x is 1 over f of x, which is 1 over x squared. Okay. I should say any real number, but right now we're only talking about real numbers. Talk about complex numbers a little later in the course. So I with the understanding that we're only talking about real numbers, any real number you put in is okay. Well, that's you can't handle 0. F of x can be any number greater than 0. Greater than or equal to 0. Okay. f of x can pass on 0 to the g of x function. That can't be. So we've got to exclude x equals 0. And then the domain of g of f of x is again going to, it's going to be the same as this. And of course, it's the same expression. It's 1 over x squared either way. Where do I have? We got 1 over x squared here. We got 1 over x squared here. What we're thinking a little bit about is, you know that neither one of these is defined for x equals 0 just by looking at the formula. But you want to understand is the reason x can't be 0 here in f of g of x is you can't plug 0 in at this point. Okay. The reason this one has to exclude 0 has nothing to do. You can plug 0 in at this point, but you can't pass 0 on to this function. Okay. And that's why you have to exclude 0. It's a slightly different reason. It's a subtle point, but worth thinking about. Okay. Now, we don't want to spend any more time on this because you've either been to it in your course or you get into it quickly. Okay. So if you want me to clarify things a little later, if you have specific questions that come out of your course or out of what you're seeing in open math in this course, we can deal with it. Otherwise, then we want to talk about transformations. Okay. So okay. Here's the graph of some function f of x. Can't give you a formula for it. I can work it out. I can make up a formula. The third degree polynomial that does that, but actually have to be fourth degree polynomial. Have to turn around, but okay, there we go. Anyhow, the graph of f of x is going to look like this. So what is f of 4? Well, there's a good reason you can't tell me because I don't have a scale on this graph, right? Okay, so I'm going to put a scale on this graph. I'm going to say 10 is here. And I'm going to say 30 is here. Okay. Now, what do you think f of 4 is? Just write down a number in your paper that you think is kind of close to what you would get for f of 4. Let's see, you did pretty well with that. First of all, you got to figure out where 4 is. But if 10 is here, well, halfway is here, 5 would be about here. 0 is here, so I guess 4 is maybe about here. And then we simply draw the line, the x equals 4 line, and see where it's graph. Okay. And then we draw a horizontal line, find the y coordinate, and almost everybody had a result, and I think they were all between 20 and 25. 25 is the most common one, so just make as many people feel good as I possibly can. You're gonna say, okay, let's say it's 25. Hey, you want an honest estimate, you know, you subdivide 30, divide that in half, there's 15. And, you know, then you divide this into 3 parts here and here. 25 is pretty close, maybe 24. Mine's a little lower than 25, but I couldn't argue against 25, okay? Not from a visual, not from where you're sitting. I couldn't argue against 20, it's just depends how you look at it. Okay. Now, if you thought it was 10, nobody did. But if you thought it was 10, you'd say, yeah, they found that looking right. Okay. Okay. Now, that little wavy equal sign means approximately 25. We're going to take 25 as the value, but we know it's an approximation because we got it off of a graph. It's not exact. Okay. Now, I want you to do something here. F of 4 minus 10. And again, you can make your estimate. Give you a minute to make your estimate. I kind of trust you to do that. Okay. Well, 4 minus 10 is 10 units to the left of 4, right? So there's 10 units. We go 10 units to the left of 4. We end up about here. And of course, it's -6. We don't have a formula. We call it 4 minus 10 if we want to. So we just move 10 units. This arrow represents movement of -10. Okay. So the line x equals 4 goes over to the line x equals 4 minus 10. And you make an estimate, and you there's your estimate. And that looks like it's about 8, let's say. Let's just say that's y equals 8. Okay. Now, if we move this entire graph 10 units to the right, we get, well, this point here, move 10 units, and it'll be here, won't it? Okay. And let's say this point here will move 10 units. We get a point here. And we go all the way to the right and move back 10 units. I'm going to get to one here. We're going to get a point like this. Okay, so that if we move the whole graph 10 units to the right, It looks something like that. Oop. Yeah. And here it's starting to go back up a little bit. Anyhow, you get the idea, right? Just take this curve, grab it, move it 10 units, right? It might look something like this. I didn't do a great job over there. Trying to not obliterate the 25, I should have gone a little lower. Well, this graph is a graph. So I had a good place to label it, should have planned better. This is a graph of a function we can call g of x. It's equal to f of x minus 10. Now, what is g of 4? Well, since we moved this point 10 units right to get this, it's going to be in the y equals 8 line, isn't it? I mean, you can see it. Here's 4. Here's your g of x curve. It's blue. Okay. And right there is your value of f of g of 4. Okay. Since g of x equals f of x minus 10, g of 4 is f of 4 minus 10. Off the board here. Okay, again, just we saw that f of 4 minus 10 was about 8 because we take the x equals 4 line, we move it over 10 units worth the x equals 4 minus 10 point. And that puts us on this vertical line, and there's the value of f, which I estimated to be 8. Okay, you might have had a different answer. So now, if we move every point of this graph 10 units to the right, what I'm saying is, because of everything we've talked about here, that g of x is f of x minus 10. That's the blue graph. And the graph of f of x minus 10 is the graph of f of x shifted 10 units to the right. That's hard for people to understand because you got a minus there. You think you're going to move everything to the left. Okay. No, you look to the left because it's going to come to the right. Whatever way you want to look at it. So I'm going to say, and this is a big deal. There are rules for transformations. And the one that's hardest for people to understand is this. Okay, maybe a little hard to read. It's a big important statement, so I wish I'd left myself more room, but that's it. It's the graph of f of x minus 10 is a graph of f of x shifted 10 units to the right. Now minus 10 is to the left, but f of x minus 10 shifts the graph of f of x to the right. Okay, and you can see that from this example. And you want to think through this example until you really understand it, so you don't make mistakes in shifting the graph, okay? Okay, well, we generalize the rule now, same rule, but kind of saying the same thing, except we don't have x minus 10, now we have x minus h. So the graph of g of x is a graph of f of x, but it's shifted opposite to the way it looks like it ought to shift. Okay, it's shifted plus h units, and I say horizontally, because h could be a negative number, and then you'd be shifting to the left. Okay? And that's a little confusing. So for example, a g of x equals f of x minus h, where f of x equals x squared. So what's a formula for g of x? Take a minute, just a few seconds actually, and write it down. Okay, well, g of x equals f of x minus h, where f of x equals x squared. So f of x minus h equals what? Well, x has been replaced by x minus h. We replace x by x minus h. Okay? And that's not x squared minus h squared. It's x squared minus 2xh plus h squared. These are distributed along the square of that. People think that squaring distributes over an addition or subtraction, and it doesn't. Okay? Try to get that picture out of your head, because it's really easy to fall into that. Okay, so anyhow, f of x minus h equals x minus h squared. Now let's say that we give h a value. H equals -3. Then g of x equals f of x minus -3 equals what? Well, it equals x minus -3 squared, but can you simplify that? Well, minus -3 is x plus 3. Probably ought not to have the plus sign in front of that h, because that could be confusing. Okay, so h is -3. Now, if we have a graph of the squaring function, which might look something like this, where this is -2, this is 2, this is y plus 4. And then, of course, it keeps going. How are we going to get a graph of g of x? The rule says it's going to be shifted h units horizontally. What's h? H is -3. If we shift every point -3 units horizontally, I don't know how I'm going to mark the vertex. I don't have my red chalk. Or confused students in my section. Okay, right there's the vertex, right? Where's the vertex going to end up? It's going to shift -3 units. It's going to be over here at x equals -3. Okay, so the vertex shifts -3 units. Okay, so does every point of the graph. So the new graph is going to take every point and shift it that far. So this point will move -3 units, and that's going to put it about here. And this point will move -3 units, which will put it over about here. And your graph is going to look like this. And of course, it's going to be symmetric about the other side. I don't have enough board to do this half of the parabola. But here is the graph p of x equals x plus 3 quantity squared. Okay. Now, the other transformations are easier to see, I think. So I'm going to let you read about them and look at the videos and stuff. But this is the one that confuses the heck out of people and people make mistakes on. They make mistakes in the other ones too, but not as bad. And it's just getting the sign wrong. There's a reason that x plus 3 shifts the graph 3 units to the left. It doesn't matter if it's the squaring function or the exponential function or the reciprocal square function, reciprocal function, cubic function, and move 3 units to the left when you replace x by x plus 3. F of x plus 3 will always be 3 units to the left of f of x. F of x minus 3 would always be 3 units to the right of f of x. You got that much. I think that's a pretty good introduction. One other thing you can do, let's say h of x is f of x plus 3 minus 4. Well, f of x plus 3 is x plus 3 squared minus 4. Still f of x is equal to x squared. Okay. What's the graph of f of x plus 3 squared minus 4 look like? Well, it looks like you take this and shift it 3 units to the left, and then all your y values are going to decrease by 4, so you're going to have to shift it 4 units down. And the minus 4 does shift it 4 units down. Okay. A plus 3 here shifts it -3 units horizontally. The minus 4 here shifts it -4 units vertically. So you can imagine what that looks like. Just take this graph, move it over here, and then move it down 4 units. It's going to be about here. Okay. And there are reflections and vertical stretches. And you stretch the thing out or compress it, make it flatter or make it sharper. Multiply your y's by 2, and this point goes all the way up to here. So it gets skinnier. Okay, well, you're gonna have to read about that. It's not too hard to understand. We might need to clarify some of it next time. Now, transformations are a big deal, because you can take any of your basic functions, move them anywhere, and you can squash them down or stretch them out or flip them over or flip them this way. Okay? Reflect them this way, reflect them this way. And it's real easy to do. It's real easy to write out the functions. It's real easy to write out the rules. Okay? So you can get that down. Because if you haven't seen it in your class, you're going to see it fairly soon.